classify alcohols and haloalkanes. So we can classify haloalkanes and alcohols as either primary, secondary, or tertiary, depending on where their functional group is attached. What do I mean by this? Well, here is an example of a primary haloalkane. So it's a primary haloalkane because the bromine functional group, the halogen, is the carbon that it is attached to. That's this carbon, let's just see, this carbon that we've just shown here. It is bonded to one other carbon. So we're looking at the carbon that the halogen is attached to. How many other carbons is it bonded to? It's bonded to one, so this is called a primary haloalkane. Well, in this next example, here is an alcohol. Now you can see that the alcohol functional group is at the top here, and it's bonded to this carbon in the middle. Now that carbon in the middle is itself bonded to two other carbons. Because the carbon that is bonded to the functional group is bonded to two other carbons, it's classified as a secondary alcohol. Now a tertiary is when the carbon that's bonded to the functional group is bonded to three other carbons. So here the functional group is a chlorine. The carbon it's attached to is right here in the middle, and there are 1, 2, 3 other carbons attached to the carbon that is attached to the functional group. That makes this a tertiary haloalkane. Primary, secondary, tertiary, and we identify and classify them based on how many carbons are attached to the carbon that is joined to the functional group. So this is a type of question we might be asked. 2-chlorobutane is a secondary haloalkane. Draw a tertiary structural isomer of 2-chlorobutane and explain why it is called tertiary. So here's here is the structure of the isomer of 2-chlorobutane. So what is an isomer? A structural isomer is you have the same formula, the same number and type of atoms, the same molecular formula, but they're arranged in a different way. So instead of having 4 carbons in a row with the chlorine coming off the second carbon, what I've drawn here is a isomer of it that is tertiary. Now it is tertiary because the carbon in the center that's bonded to the chlorine is 3 carbons attached to it. And I explain this because it's asked me to explain why it's classified as tertiary. This is a tertiary haloalkane as the chlorine functional group is attached to a carbon which itself is attached to 3 other carbons. And that's the type of question you might have to answer on classifying something as a primary, secondary, or tertiary. Draw whether it's primary, secondary, or tertiary, and say why it's primary, secondary, or tertiary. Hey, thanks for watching this video. Hopefully this has made you more confident with your chemistry. Don't forget to like, subscribe, or leave a comment about anything that you want to with this video or any questions you have. I'll see you later.